Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on configuring OSPFv2 adjacencies. So let's take a look at our lab objective. It says before routers in the OSPF area can exchange information, they must obtain a neighbor relationship, which is known as an adjacency. An OSPF router that has not yet exchanged information with a potential neighbor is considered to be in the down neighbor state. OSPF routers establish adjacencies by sending hello packets. In this lab, you will implement, verify, and explore OSPF adjacencies. So if we take a look at our lab topology that we're going to be working with, we can see that we have three routers. Router 1 and router 2 are connected via this serial link. All right. So this point-to-point link, and then we have router 1 and router 3 connected via an Ethernet link. And then you can see router 2 has its own network, and router 3 also has its own network, okay? With two switches inside of both of those networks, or one switch inside of both of those networks, okay? So let's take a look at our commands that we're going to be using for this lab. We have configure terminal, which enters global configuration mode from privilege exec mode. We have enable, which enters privilege exec mode. We have end, which ends in exits configuration mode. We have exit, which exits one level in the menu structure. We have interface type number, which changes from global configuration mode to interface configuration mode. We have IP OSPF process ID, area ID, and this places an interface in a specified OSPF process and area. We have network address, wildcard mask, area ID. This activates OSPF on a specified network and places the matching interface in the specified area. We have ping IP address, which sends an ICMP echo request to the specified address. We have router OSPF process ID, which enters router configuration mode for an OSPF process. We have show IP OSPF interface type number brief. This displays the OSPF interface information. We have show IP OSPF process ID area ID neighbor. This displays the OSPF neighbor information. And we have show running config, and this displays the active configuration file. And we also have our IP address table, and we would definitely reference this table as needed throughout the lab. You can see all of the different devices within the lab and all of their IP address and interface information as well, and subnet mask, okay? So let's go ahead and jump into this lab. We're going to keep our lab topology in the top left. We're going to be doing our lab readings in the top right, and we're going to be doing all of our configuration down here at the bottom, okay? So let me adjust my camera just a tad bit, about right there. I like it right there, okay. So task number 1, it says configure and verify OSPF. It says in this task, you will configure OSPF on router 1, router 2, and router 3, thereby establishing OSPF adjacencies. In addition, you will learn how OSPF establishes adjacencies and what criteria must be met for an adjacency to form. All right, so it says from PC1, attempt to ping PC2. As you can see, they are in two different subnets, and we can tell that by this 100 and this 200 being right here. They're in two different subnets. It says the ping should fail because no routing protocol has been configured on the network. So if we go to PC1 and we try to ping to 10.10.200.100, that is on a different network. And as you can see, on this PC, we're getting host unreachable messages. And that is because on this router 2 that PC1 is connected off of, this router does not know how to get to 10.100.100.1. Excuse me, it does not know how to get to 10.10.200.100. All right, so since it does not have a path to that network, it is going to drop those packets. So number 2 says OSPF process IDs, which are used to identify a given OSPF process on a router, are locally significant. Therefore, process IDs do not need to match between neighboring routers. On router 1, configure a new OSPF router process. Use a process ID of 10. So let's go to router 1. We're on router 1 right now. Let's do an enable. Let's do a configure terminal. Let's go into router configuration for OSPF, and we want to use a process ID of 1. Of 10. I'm sorry, of 10, and hit enter there. All right. Now it says on router 2, Configure OSPF router process with an ID of 20. Wait 30 seconds. Do router 1 and router 2 establish an OSPF adjacency? Why or why not? So let's go to router 2. Let's do an enable. Let's do a configure terminal. And let's do a router OSPF with a process ID of 20 and hit enter. And it says wait 30 seconds and see does an OSPF adjacency come up. And I don't even have to wait the 30 seconds. I know an OSPF adjacency is not going to come up because we have not configured any interface to operate in OSPF. So we do have the process IDs configured on both of these routers, on router 1 and router 2, but we do not have any interfaces participating in OSPF. So that is not going to form an adjacency just putting the process IDs on these routers, okay? And we're waiting 30 seconds because if we look at this topology that we're working with, we have a serial connection between router 1 and router 2. And as we know, OSPF hellos for a serial point-to-point connection is 30 seconds, all right? So on number 4, it says on router 3, configure a OSPF router process with an ID of 30. What other configuration tasks needs to be performed on the routers in order to enable the routers to establish OSPF adjacencies? So if we go to router 3 and we do an enable, we do a configure terminal, and we do a router OSPF of 30 and hit enter, we did that. Then we configured the process ID and it asked us what other configuration tasks do we need to perform on the routers in order for the routers to establish adjacencies. And in order for the routers to establish adjacencies, we have to configure the interfaces on each router on both sides of the connection to participate in OSPF. And then those routers will establish an adjacency, okay? So it says on router 1, router 2, and router 3, place each device in interface configuration mode for the loopback 0 interface. Configure the correct OSPF process on each interface. In addition, configure the interface to operate in OSPF area 0, which is known as the backbone area. Do the routers form adjacencies now? Why or why not? So let's go to each router and configure the loopback interface to participate in OSPF. So if we do an exit, we're going to interface for loopback 0 on router 1. We want to do an IP OSPF. We want to do a process of 10 because that is what we configured on this router. And we want to put this in the backbone area, or this interface into the backbone area, which is area 0. And let's say enter there. We want to do the same thing on router 2. Let's do an exit. Let's go into interface for loopback 0. And we want to do an IP OSPF, a process of 20 on this router. And we want to do an area of 0 to put it in the backbone area. And we also want to do the same thing on router 3. So let's do an exit. Let's go into interface configuration mode for loopback 0. And let's do an IP OSPF, a process ID of 30. And we want to do an area 0 on router 3 as well. All right. Now it asks, do the routers form adjacencies? And they're not. And that is because of what I just explained earlier. Just because we configured loopback interfaces are specific to the device itself. It is not a connection between two devices. So once we put these loopback interfaces to participate in OSPF, that is not a network between the network. The loopback interface has nothing to do with the network between the two devices. We have to have a network between the two devices, and they need to participate in OSPF before we can have an adjacency form. So the loopback interfaces are internal to the devices themselves. So it is not going to establish an OSPF adjacency from loopback interfaces being configured on the routers, okay? So on number 6, it says on router 1, place the device in OSPF router configuration mode for OSPF process. Oh, and let me do this right quick. I can also do a do show IP OSPF interface brief. Oh, I can do a do show IP OSPF interface. And if this is exactly what I was looking for. So we can see that the loopback interface is configured. to participate in OSPF, but we can see the loopback interface is treated as a stub host. So what does a stub host mean? That means that this router is the only router participating in this specific network on OSPF. That is what a stub network is. It has no other networks attached. It's a stub network. That's what a stub network means, okay? So let's get back to the lab. It says on router 1, place the device in OSPF router configuration mode for the OSPF process with an ID of 10. From this mode, configure both the serial 00 interface and the fast Ethernet 00 interface to operate in OSPF area 0. Use a single command to complete the configuration. What wildcard mask did you use and why? So first I want to go to router 1. All right, let's give an exit. Let's go into router configuration mode. So let's do a router OSPF 10. All right. And what we want to do is we want to configure the serial 00. So on router 1, that is the connection down to router 2. And we also want to configure the fast Ethernet, which that is the connection down to router 3. We want to configure both of those interfaces to operate in OSPF area 0. And we want to use a single command to do that. So if we go down in our table, we can see on router 1, the serial 00 interface has an IP address of 203.0.113.1. It has a slash 30, that's a slash 30 subnet mask. And we have a, on the fast Ethernet 00 interface, we have 203.0.113.5, and we also have a slash 30-bit subnet mask, okay? So if we have two 30-bit subnet masks and we have both of these addresses, we can encompass both of these addresses with a slash 29 network. So that'll give us 8 usable it would give us 6 usable addresses, 8 addresses total, but 2 of those are reserved for the network and broadcast addresses. All right. So we want to use the wildcard mask of 0.0.0.8, which is a slash 29, to have both of these networks participate in OSPF. So that is why we're going to use that subnet mask. So let's do a network of 203.0.113.0. We want to do a 0.0.0.8 for the slash 29. And we want to put this in the backbone area or area 0. Hit enter there. All right. So on number 7, it says on router 2, place the device in OSPF router configuration mode for the OSPF process with an ID of 20. From this mode, configure the serial 00 interface to operate in OSPF area 0. Use a wildcard mask that is equivalent of the subnet mask configured on the interface. How much time passes before the routers form an adjacency and why? So on router 2, let's go into router configuration mode. So let's do a router OSPF for process ID of 20. And if we take a look at router 2's IP address information in the IP address table, the serial 00 interface has a slash 30-bit subnet mask. So we want to configure a subnet mask of 0.0.0.3 because that will be a slash 30 in wildcard mask form. So let's do a network of 203.0.113.0. And we want to do a subnet mask of 0.0.0.3. And we want to put this in area 0 and enter there. All right, so let's see how much time is going to pass before we get this adjacency. It should be between 10 and 30 seconds. And that is because if we go back up, we can see that the link between router 1 and router 2 is a serial link. So the hellos are sent every 30 seconds on serial links. On the Ethernet link, they're sent every 10 seconds, okay? So let's give it a little bit of time. Hopefully we can get this adjacency come up if we did everything correctly. Let's do a do show IP OSPF interface brief. Okay, do show IP OSPF neighbor. So we don't have any neighbors. We have this participating. 000. That looks good. Let's go back to router 1. Let's do a do show IP OSPF interface brief. Okay, so the only interface participating in OSPF on this router is the loopback 0 interface. So I must have configured something incorrectly, or it must not have registered the other interface that I configured on this router. So on router 1, it said the serial 00 interface and the fast Ethernet 00 interface. So yeah, we encompass both of those inside of this address, this network command. I'm not sure why it didn't register. Let's do a network. Let's do a do show IP protocols. Let's troubleshoot this. Yeah, so it's routing for network 203.0.113.0. Oh, okay, I know. I see what I did wrong. I did a .8 instead of a .7. That should be a .7. And yeah, that should be a .7. So let me do a network, no network of 203.0.113.0, 0.0.0.8 area 0. We want to do a network of 203.0.113.0.0.0.7 area 0. All right. That adjacency should come up now. I did 0.0.8 instead of 0.0.0.7. Okay. Let's give it a little bit of time. Let's do a do show IP protocols. Yep, that is what we want. 0.0.0.7. Okay, yep, and it took about 30 seconds, and we can see that adjacency just came up with router 2, and we can tell by this loopback interface. If we look at the IP address table, we can see that that is router 2's loopback 0 interface. All right, so number 7, it says on router 2, place the device in OSPF router configuration mode for the OSPF process with an ID of 20. From this mode, configure the serial 00 interface to operate in OSPF area 0. Use a wildcard mask that is equivalent to the subnet mask configured on the interface. Okay, so we just did that one. So it says on number 8, it says on router 2 and router 1, display the OSPF router process information of the running config. What differences do you notice? Why have routers formed an adjacency despite these differences? Excuse me. So if I do a do show run over here, and I go down to the OSPF configuration, I do the same thing on router 2. Let's do a do show run over here. Go down to the router configuration. We can see that they are using 2 different process IDs. So this one is using 20 for router 2. This one is using router 10. Process 10 for router 1, and they're using different subnet mask, but they both are living on this network. The link between router 2 and router 1 lives on the 203.0.113.0 network. So they're able to exchange hellos on both sides of this link, and because of that, they are able to form an adjacency. Only thing that needs to match is the hello timer, the dead timer, the OSPF area, and any OSPF authentication credentials. Okay, so it says right here, it says on router 3, place the device in OSPF router configuration mode for the OSPF process with an ID of 30. From this mode, configure the fast Ethernet 00 interface to operate in OSPF area 0. Use a wildcard mask that is equivalent of the subnet mask configured on the interface. When an adjacency forms, note the OSPF router ID of the neighboring router. Why did OSPF select this value for the router ID? So let's go to router 3. Let's give an exit. Let's go into router OSPF for process 30. Let's do a network. Let's go to the IP address information. We want to do it on the serial 00 interface. So that is the fast Ethernet 00 interface, which is 203.0.113.6. And it has a /30-bit subnet mask. So we want to do a network of 203.0.113.0 0.113.4. And we want to do a O.O.O.3. And we want to do an area of 0. We want to hit enter there. And the router ID that we should be seeing on router 3 is router 1's router ID. So we should be seeing 1.1.1.1. And the reason why OSPF chooses that router ID is because that is the loopback interface configured on router 1. And as we know, OSPF, if we do not specify router ID, it will choose the highest loopback interface to be its router ID. And it does this to keep a stable IP address throughout the OSPF process, okay? So, number 10, it says on router 2 and router 3, ensure that each device in the OSPF router configuration mode for the locally configured OSPF process. Next, configure each router's Fast Ethernet 01 interface to participate in OSPF Area 0. Why do you not receive OSPF adjacency messages after you complete this configuration? So first, on router 2, let's go down to our router table information. And we want to configure the Fast Ethernet 01 on router 1 and router 2. So the Fast Ethernet 01 on router 2 is 10.10.100.1, and it is a /24-bit subnet mask. So we want to do a network of 10.10.100.0, O.O.O.255, area 0. All right. Do the same thing over here on router 3. Let's do a network of is router 3's Fast Ethernet 01 has 10.10.200.1. So we want to do 10.10.200.0, O.O.O.255, area 0. Hit enter there. And it says, why do we not receive a message after this is completed for an OSPF adjacency? And that is because the OSPF adjacency is for router 1, and that adjacency is already up. Same thing with router 2. Its adjacency is with router 1, and that adjacency is already up. So just because we put another route in the OSPF process does not mean we're going to have another OSPF adjacency come up, okay? So number 11, it says, on each router in the topology, verify that the OSPF neighbor relationships are in the up state and full state. What differences do you notice in the relationship between router 1 and router 3 when compared to the relationship between router 1 and router 2? So let's do a do show. Oops, did not mean to do that. All right, let's do a do show IP OSPF interface brief. All right, let me do a do show IP OSPF neighbor. I think that should give us, yeah. All right, same thing over here. Do show IP OSPF neighbor. And same thing over here on router 1. Let's do a do show IP OSPF neighbor. All right. And we can see that we do have the full states and the BDR states on each of these routers. Is full state. And same thing over here, full state on router 3. And the difference we're seeing is on router 3, we have a full and DR combination. On router 2, we only have the full with a dash. And on router 1, we have full with a dash to router 2. And we have full and BDR with router 3. And that is because we do not do a DR or BDR election with a point-to-point link. We only do that on broadcast or Ethernet links, okay? So that is why router 2 does not have a BDR election occurring. And same thing on the connection between router 1 and router 2 does not have a BDR or DR election occurring because it is a point-to-point link. But the connection between router 1 and router 3 does have a DR and BDR. So we can see the DR is over here on router 3 and the BDR is router 1 because of the loopback interfaces. Okay, so number 12 says from PC1 attempt to ping PC2, the ping should succeed now. And that's because we exchanged routing information. So now we are able to ping PC2. Before we were getting host unreachable. But since we configured dynamic routing, and the dynamic routing we configured within this network is OSPF, those routes are able to be exchanged. And because of that, PCs are able to communicate with other PCs. Okay. So now let's hit grade, and hopefully we did everything correctly. And it looks like, okay, yeah, and we did. So I appreciate you guys for watching this one, and I'll see you in the next one.